Good afternoon, Elizabeth. I see your microphone is off, but let me start here. So a good afternoon. Before you joined us, we were looking at this topic of matrices. So we're looking at this topic of matrices. And we had seen the multiplication, the addition, the subtraction, and I guess I'll get those videos and then forward them to you, such that you can be able to view them. Then today I wanted us to briefly look at the inverse of a matrix. So when you get time, you'll come and go through the videos that are in this topic. They are quite a number, so you go through them to understand better how the matrices, how we do operation on matrices. So the multiplication, the addition, the subtraction, and now what we are going to cover, which is the inverse of a matrix. So let me stop sharing this, then I share something that we are going to use. So I said today we are looking at the inverse of a matrix, and our emphasis of today's topic. So we are saying So the inverse of, so we are going to begin with the determinant. Since it is also involved, we use it to find the inverse of the matrix. So here we are given a matrix M, which is A, B, C, and D. And we are saying the determinant of the matrix M, denoted by det M, is defined as, so determinant of M is the same as getting A, the product of the major diagonal. So this matrix has two diagonals. So the major, which slopes from left to right, and then the minor. So this one is the minor, and this one here is the major. So the major diagonal. So when we are finding the matrix, the determinant of the matrix, we get the product of the major diagonal, which would be A times B. Then we subtract the product of the minor diagonal, which is C times D. So in simple terms, the determinant of the matrix M is going to be A times D minus C times D. So this one can be simplified as AD minus C. I think this one should be B minus CB. So this will be giving us the determinant of a matrix. Is it clear, Shania?
Yes.
Okay. So we can go ahead.
I don't know.
So we are given a question here to find the determinant of a matrix N, which is negative 1, 2, 3, and 1. So what are we going to do?
We are going to get minus 1 times 1, negative 1 times 1,
Yes.
minus 3 times 2.
Minus 3 times 2. What is negative 1 times 1?
Negative 1.
And then 3 times 2?
6.
6. And then what would be 1 minus 6?
Negative 7.
7. So we can say, therefore, determinant of N is equal to negative 7.
7.
Okay. So there is another question for us. Find the determinant of the matrix R, which is 4, 6, then 10, and 15.
Pardon?
Okay, let's first find this. Determinant of a matrix M, which is 1, 2, 4, 5.
One times 5. Minus 4 times 2.
So 1 times 5 is 5.
5.
Then 4 times 2?
8.
8. And then 5 minus 8?
Negative 3.
Negative 3. Okay. And then we have another matrix R, which is 4, 6, 10, and 15.
Whatever it should be. Stupid, my.
So here the determinant will be 4 times 15. Then we subtract 10 times 6. So 4 times 15 is 60. And then it's 10 times 6 is also 60. So when we get 60 minus 60, that will give us a 0. So it gives us a 0. So the determinant of R is equal to 0. So matrices whose determinant is equal to 0, we call them singular matrices. So those are matrices whose determinant is equal to 0. So now after knowing how to find the gradient, the determinant of the matrix, so we can now go ahead to find the inverse. So we are saying that the inverse of the matrix, M, which is equal to A, B, C, and D, is denoted as M to power -1. So M inverse. And that M inverse is defined as 1 divided by the determinant, and then we multiply by some books they call it new order matrix, and in some others they call it adjunct matrix. So in this adjunct matrix, so we come to our original matrix and we interchange the elements in the major diagonal. So that is why we are having a D has shifted from where it was to this place, and then A has shifted to where the D was. And then in the minor diagonal, we just change the signs of the elements. So if it was positive, it becomes negative. And if it was negative, it becomes positive. Let me just repeat it. So to get the adjunct matrix, we interchange the elements in the major diagonal. So the D shifts upwards and the A down to where the D was. So we have D and A. Then in the minor diagonal, the C changes. Here it is positive, so it has changed to negative. The B is positive, it has also changed to negative. But in case the C is negative here, it will change to the positive. So that is the procedure of how we find the matrix, the inverse of a matrix. Let us look at some examples here. So our example 1, we are requested to find the inverse of a matrix P, which is equal to 5, 4, 3, 2. So what are we going to begin by finding? What are we going to find first?
The adjunct.
Okay, we can begin by finding adjunct. What is it equal to?
2
Yes.
minus -4,
Yes.
-3,
Yes.
5.
Right. Thank you. Then what did we find next?
The determinant.
Determinant. So this will be equal to determinant of P. Yes.
We find the one for the original.
Yes, the one for the original. Determinant of P.
5 times 2 minus 3 times 4.
So 5 times 2.
10.
Then we subtract 12. So
12.
10 times 12 gives us
-2.
-2 as the determinant of P. So we are going to say P inverse is equal to 1 over determinant of P. Then we multiply by the adjunct matrix. So this is the same as 1 over -2 into now the adjunct, which is 2, -4,
Negative.
and
-3, 5.
okay. So we can leave this in a more precise way by saying 1 divided by -2 is -1/2 into 2, -4, -3, and 5. So this will be the P inverse. Is that okay?
Yes.
Okay, so we can proceed. So find the inverse of the matrix Q, which is 2, 3, 5, 7. So still we are going to begin by finding the adjunct matrix, which is what will be the adjunct matrix?
7, -3, -5, 2.
Okay. Then we find determinant of Q. What is the determinant of Q?
2 times 7 minus 5 times
Minus
5
-5
times.
times -3.
Teacher, I thought you were supposed to use this one, the original one.
Yes, you are saying something?
Isn't it supposed to be 5 times 3 for the original
Hey,
matrix?
okay, sorry about that. Okay. So 2 times 7, 5 times 3. So 4 times 7 is 14 minus 15, and this gives us -1. Okay. Then Q inverse is going to be 1 over determinant of Q, then we multiply by adjunct. So Q inverse is going to be 1 over, our determinant was -1, then multiply this by the adjunct matrix, which is 7, -3,
-3,
-5, 2. So one divided by -1 is -1 times 7, -3, -5, and 2. So since it is a single value here, we can multiply inside. Okay.
Yeah.
So it will be -1 times 7, and that gives us,
-7,
and -1 times -3,
3,
-1 times -5,
5,
and -1 times 2.
-2.
So this will be the inverse of what? Q.
Of Q.
Yes. So we have another one here, determinant of R. So adjunct matrix of R is equal to
4,
yes,
2,
yes,
3,
yes.
2.
Okay. Then we now find determinant of R. So that would be 2 times 4 plus -3, -2. So 2 times 4,
8,
8. And we subtract -3 times -2,
+6.
+6. So this will give us 2. So we say our inverse is equal to 1 over determinant of R multiplied by adjunct. So which would be our inverse is equal to 1 over 2 into 4, 2, 3, 2.
True.
Yes, I think we can stop there. Okay, so that is where this one would stop. Is that okay?
Yes.
So we have talked about the inverse of the matrix, which is here. Are you able to see my screen?
Yes.
Yes. So the inverse of the matrix. So in your free time, you come and watch these videos here. Okay.
Yes. Yes.
Yes. So this first video talks about the identity matrix. So the identity matrix is a matrix such that when you multiply it with another matrix on the left or right hand side, you get that very matrix. Okay. And this
Yes.
identity matrix, let me share whiteboard. So it is abbreviated as I and is 1, 0, 0, 1. Okay. So the elements in the major diagonal are 1, and then in the minor diagonal they are just zeros.
Yes.
Okay. So this is a
Yes.
2 by 2 identity matrix.
Matrix.
Yes. So we have as well read that if we multiply it either on the left or right of a matrix, we get that very matrix. So we can try it out. So let us see 2, 3, 1, 4. Multiply it by 1, 0, 0, 1. You still remember how to do the multiplication?
Yes.
Okay, so we shall get
2
yes,
times 1 plus 3 times 0. Then down. Then the next one we get 3 times 0.
not 2. This times this. And this, yes.
Yes. 2 times 0 plus 3 times 1.
Then down.
1 times 1 plus 4 times 0. And 1 times 0 plus 4 times 1.
Okay. So what is 2 times 2? 2 times 1?
2.
3 times 0?
0.
Yes, 2 times 0?
0.
Plus 3 times 1?
3.
1 times 1?
1.
Plus 4 times 0?
0.
Then this would be 0 plus 4. So after adding
Yes.
to this, we shall still come up with 2, 3, 1
1, 4.
and 4.
4.
Yes. So still, if we begin with this matrix, with the identity matrix and multiply by this matrix, we shall still get that matrix, which is 2, 3, and then 1, and
4.
a 4. Okay.
Yes.
So now I want you to, so after you have watched these videos here in this unit, all of them, okay?
Yes.
I want you to come and attempt this assignment, Matrix Senior 2 assignment, okay?
Okay.
You know how to do it? You know how to, so
Yes.
you come and click on this plus,
Yes.
okay? Then it loads. So you'll do these numbers. I don't know whether you know how to type or you write and then take a photo or something, okay?
Yes.
And then when you click on start assignment, okay? So it brings this part here. So it gives you 10 days to do that assignment. So you, after doing it, you click on this select file, and then it takes you to where you can pick the assignment where you have saved it. Is it okay? So in most cases, you
Yes.
save it in documents. Okay. Then when you click, it will
Yes.
be able to come there. And then after it has come, you just say submit what? Assignment.
Assignment.
Okay, is that okay?
Yes.
Okay. If there are no other questions from your side, we shall stop here. Any questions?
No.